Okay. So 150 at an angle of the angle of projection theta is 35 degree above the horizontal. If the body is short from the ground, calculate the time taken to reach the maximum height. So of course, we've gone through the theory. So we are not going to derive. We just apply them. Time taken to reach the maximum height t, this is giving us u sine theta over g. Okay, u as given to us is 150 times the sine of 35 degree, and we are told that we are to take g as 10. So divided by 10, and this is equal to 15. Of course, 10 will cancel, the 0 will cancel this. So 15 sine 35. Class, what is 15 times sine 35? What is 15 times sine 35?
8.6.
So this is 8.6 seconds. Then the next question B, the time of flight. So this is A. The B question is about the time of flight. Theoretically, time of flight is equal to 2 times the time taken to reach the maximum height. Or this can also be expressed as 2u sine theta over g. The truth is that when you understand this, the formula doesn't matter. Once I have the time taken to reach the maximum height, then the time of flight will just be 2 times 8.6. And this must give us 17.2 seconds. If you are also an admirer of equations, then if you want to use the formula, T is equal to 2 times 150 times sine of 35 divided by 10, the value would be the same as 17.2 seconds. So this is it concerning the time of flight. Then C. The C question is about the range. The range of a projectile is the total horizontal distance traveled. And this is given by the product of the constant horizontal velocity so the value of the constant horizontal velocity times the time of flight. If you don't want to use equation, 150 times sine 35 times the time of flight, which is 17.2. So what is 150 times sine 35? 150 times, that's approximately 123. Is that correct? Class, is that correct? Hello, can you hear me?
Yes, please.
It's 100 and approximately 125, 23, correct? Yes.
So it's supposed to be tan 35 or cos 35.
Yes, theta is 35.
So is it supposed to be sine or cos?
Oh, it's cos. Thanks for the information. So this is cos of 35. And that is approximately 123. Is that correct?
Yes, please.
Okay. So what is 123 times 17.2? 123 times 17.2. Hey, don't waste time. Farida and Co. Asian. Melchizedek. Can you hear me? Pascal,
Yes,
go
please.
ahead. Go
Sir,
ahead.
please is 2,115.6.
Next time, don't raise your hand to answer. Okay, there are times where I may ask you to answer. Okay. Prince Williams. Prince, you're not, I think you are, mute yourself for us. We are having a very huge effect here. Now, if you are an admirer of formulas or equations, you see, the range is u cos theta times a time of flight. A time of flight is also equal to, I'm coming. The time of flight is equal to 2u sine theta over j. Now we can also rearrange this equation to look like u squared times 2 sine theta cos theta all over j. Now, mathematically, if you have double angle, I mean sine of, it can be sine, cosine, or theta plus theta. This is the same as sine 2 theta. When you expand this, you haven't reached there. But when you expand this, the expansion of this will give you 2 sine theta times cos theta. So if 2 sine theta times cos theta is the same as sine 2 theta, then in place of this, I can also decide to put this one, because by formula they are the same. So when I do that, the range equation or formula can also be u squared over j times sine 2 theta. So this is another simple expression for the range. Now, if I want to use this, u squared is 150. U is 150. So 150 squared divided by 10 times sine of 2 times 35. Okay, class, what is the square of 150? What is 150 squared? Hello, what is 150 squared?
22,500.
Good. So divided by 10 would give us
2,250.
Yes. 2,250 times sine 2 times 35, 70. What is 2,250 times sine 70?
2,114.30.
So the value is the same. So we can easily, okay, this is giving us something 2,115. This is 2,114. Okay, yes, not so exact, but we can run it to the nearest thousands. Okay, so the point is that whether you use formula or not, you must get the same answer. So usually projectile motion, formula not so important, but I also understand there are times where we can even ask you to prove that the range is equal to u squared over j times sine 2 theta. Class, is there any question here? Is there any question? No question. So that's it with the range. With the range. What is the next question? Hello, what is the next question? The question is on the page. Oh. If you
The
want to,
velocity of the stone at the maximum height.
what is the velocity of the stone at the maximum height? Yes, what is the velocity of the stone at the maximum height? Anybody? Pascaline, what is the velocity of the stone at the maximum height? D, the D question.
122.9 meter per second.
Pascaline, how did you get that? Okay, so the velocity is such that at every point, there are two velocities acting on the body. However, when the body gets to the maximum height, the vertical component of the velocity goes to 0. Okay, so at the maximum height, vertical velocity is 0. And if the vertical velocity is 0, then it means it is only the horizontal velocity that moves the body. Okay, so the velocity of the body at the maximum height is equal to the u cos theta component at the maximum height it's equal to u cos theta. This is because the vertical component is 0. So if it is u cos theta, then the velocity of the body at the maximum height will simply be 100, and v will be equal to 150 cos of 35, which is 100 and approximately 123 meter per second. This is the velocity of the body at the maximum height. Then the maximum height reached. The maximum height reached. We can determine this using two different ways. One, at the maximum height, because final velocity is equal to 0, maximum height can be u sine theta squared over 2g. So if you want to use this formula, then 150 times sine of 35 all squared divided by 2 times 10. Calculate this for me. 135 sine 150 times sine 35 all squared. Please, let's all get involved so that we can do this within a short time. Of course, 150 times sine 35 is 86. So we have 86 squared divided by 20. Yes, Pascaline. What is the final answer?
370.
370 approximately. Are we okay?
Yes.
We can also find this using a different method. It's just good we go through this as well. If you use H is equal to UT, of course, U is U sine theta. So U sine theta times T minus half JT squared. Now, our T here is the time taken to reach the maximum height. So we have 150 times sine of 35. What is the time taken to reach the maximum height? We calculated for that. We had 8.6. Class, are you with me? Class, are you there?
Yes, sir.
No, because of network issue, when I call, respond. So I'll be sure you are there. It's raining heavily here, so it affects the network quality. Okay, so 8.6. So this times, I'm coming. Good. This times 8.6 minus half times 10 times 8.6 squared. Help me evaluate this. 150 times. Friends, mute yourself. 150 times sine 35, this is 86. So 86 times 8.6 minus 5 times 8.6 squared. Class, quickly evaluate this for me. 86 times 8.6. This is almost 740. What is 8.6 squared times 5? Class, what is 8.6 squared times 5?
Sir, it is 369.8.
Approximately 370. Is that correct?
Yes, please.
Okay, so let's subtract 370 from 840.
So I'm talking on the final answer.
That your final answer is no. I'm doing it. I'm doing it step by step. So give me the product of 5 and 8.6 squared. So what is 8.6 squared? This is 73.96, isn't it?
So 5 times 8.6 squared is 369.6.
9.8.
So approximately 370. Is that correct? Is that correct?
Yes.
Yes.
So subtract 370 from 840.
470.
470. Is that the same thing we had when we used, let's see, what did we get? We had
370.
Use sine theta. No, we must get the same we must get the same thing. We must get the same. So let's probe to see where we are only substituting the time taken to reach the maximum height in place of t. Okay, so u sine theta, ut minus half gt squared. Check 150 times sine 35. 150 times sine 35. This is 86.
86.2.
So approximately 86 times 8.6 the time minus, yes, 2 will go into this. 2 will go into 10, 5.
Sir,
Hello?
I don't think there's anything wrong with it because when I tried 86 times 8.6 minus 5 into brackets 8.6 squared, it gave me 369.8.
So approximately, and so it must be the same thing. And so I just want to check where perhaps we went wrong.
So the 86.6.
86.86.
86.
0.86.
I'm coming. So, hello, Camila.
Sir, please, the 86 times 8.6, you rather wrote 840 instead of 740.
339.
Okay. So thank you. So it must be 740. Okay, so when you subtract 370 from 740, what's the result? When you subtract that 370 from 740, what's the answer?
So please 370.
Okay, so this is the other way. Okay. Then the velocity at 6 seconds. This is where I have issues with some of you. Its velocity after 6 seconds. After 6 seconds, the body has not reached the maximum height because we just saw that the time taken to reach the maximum height is 8.6. Then, meaning after 6 seconds, the body isn't at the maximum height. If it is not at the maximum height, then there will be two velocities acting on the body. Supposing this is a sketch. This is the position where at time t is equal to 6 seconds, we have the vertical velocity, we have the horizontal velocity. And so, because there are two velocities acting on the body, the resultant must give us the velocity as 6. Meanwhile, some of you only calculated the vertical velocity and that is it. Okay. Some of you calculated the vertical velocity at 6 seconds and that was it, which is totally wrong. Equally, some of you did a great job. You got it spot on. So please determine the vertical velocity at 6 seconds, which is 86 minus, okay, 86. Let's go through it just to help those who perhaps were not following. So this is u sine theta minus gt, and 150 times sine of 35 minus 10 times 6. This is the vertical velocity at 6 seconds. This is 86. 150 times sine 35 is approximately 86 minus 60. So this is giving us 26. Meanwhile, we realize that the horizontal velocity is u cos theta, which is approximately 123 meter per second. This is meter per second. And so the resultant velocity v squared will be equal to vx squared plus vy squared. Okay, we found vx, we found vy, so the rest must be easier. So this is 123 squared plus 26 squared. And when you take the square root of this, it must give you the resultant velocity at 6 seconds. Yes, what is this value? Square root of whatever is under the bracket. Please just give me the final answer. What's the final answer? Camila and the rest of you, get involved. Yes, Franca.
Sir, please, the final answer, I got 126 meters.
400 and
126.
please, can somebody else confirm?
So I think it's supposed to be 149.
126.
Let me confirm because I'm getting different answers. So I'll confirm shortly and get back to you. S plus 26 squared. I'm also getting, yes, approximately 126 meter per second. Okay. Class, a follow-up question. Can you help me calculate the velocity after 16 seconds? Velocity after 16 seconds. 1/6, the same question. The velocity of the body after 16 seconds. And finally, the velocity of the body just before it drops to the ground. Velocity just before hitting the ground. The velocity just before hitting the ground. velocity after 16 seconds, and velocity just before the body hits the ground. So just do that, and then let me quickly take attendance, okay? I expect everyone to try. Class, be reminded that your second test will come on live. Live and color. So you're answering to the questions. Velocity at 16 and velocity just before hitting the ground. Okay, I think time is up. So what is the velocity after 16 seconds? Zion, what is your answer for velocity after 16 seconds? Can you share that with us? Zion. Hey, Zion, where are you? Melchizedek, are you there? Melchizedek.
Yes, sir.
What have you had for velocity after 16 seconds?
It's about 201.
201. Okay, anybody to confirm that for us? Sean. All right, let's see. After 16 seconds, is the body going up? Is the projectile going up or coming down after 16 seconds? Russell. Okay, Franca, Is the body going up after 16 seconds or coming down?
So I think it's coming.
It's coming down. Why do you think so?
So because
You don't have a reason. Okay. So can somebody answer? I also agree to the fact that after 16 seconds, the body is coming down. Ejewa, what is the reason?
Because we got to know that it got to its maximum height at 8.6 seconds. So
Exactly.
it's going to stop and come down.
So the body got to the maximum height at time 8.6 seconds. So after 16 seconds, which is, and then you see the time of flight is also twice this, 17.2. So meaning if this is the ground, at 16 seconds, it must be hitting the ground. So this is how you have to figure out the question. At 8.6 seconds, it has reached the maximum height. So any time beyond 8.6 means that it is coming down. Franca, are you okay?
yes, please.
What is the vertical velocity at this point? Class, what is the vertical velocity at this point, at the maximum height? Class, what is the vertical velocity at the maximum height? The vertical.
Zero.
Oh, zero. Class, do not waste time. It's zero. So it means that at this point, when it is returning, if you want to find the vertical velocity after 60 seconds, of course, you use u sine theta minus jt. This is the initial vertical velocity. Because the initial vertical velocity is zero, it means we have 0 plus because at 16 seconds, it is coming down. So it will be accelerating instead of decelerating. So plus 10 times, now know something, 16. If from the point of throw to the maximum height, it is 8.6, then what is the time remaining? Okay, the remaining time you must subtract 8.6 from 16 because it will take, supposing this is the position 16 seconds, meaning from the maximum height till when it is here, the time difference will be 16 minus 8.6. Plus, what is 16 minus 8.6? What is 16 minus 8.6?
7.4.
Come again.
7.4.
Good. So this is times 7.4, meaning after 16 seconds, its vertical velocity will be 74 meter per second. So if I want the velocity at 16 seconds, it is equal to this v squared. V squared will be equal to Vx plus Vy. And Vx is constant. Vx is 123 squared plus 74 squared. And what will be the answer? Please take the square root and everything. So 123 squared plus 74 squared.
143.5.
143.
0.54.
Okay, just get 1 dp.
0.5.
0.5 meter per second. Then some people also would solve it this way. Okay, velocity after 16 seconds will still be u sine theta, which is 86 minus 10 times 16. So 86 minus 160. What is 86 minus 160?
74.
Good. Negative 74 meter per second. And they will conclude that because it is negative, the body is coming down. I do not share that view, even though by magnitude it has the same value. Okay. But when the body, I don't share it because when the body is dropping, it will accelerate. So if you give me negative velocity, what are you saying? Okay, so these are the two ways to go about it. Don't forget, we haven't considered the horizontal velocity. It is still 150 times cos of 35. So please, this is the initial vertical, when it gets to the maximum height, the initial vertical velocity is 0. Okay, so use the time difference. If it is taking 8.6 seconds to reach the maximum height, then by 16, just subtract 8.6 from 16, and that will be the time it will take to reach the remaining time, okay, to take to reach 16 seconds. And that's it. Can somebody help me determine the velocity just before it drops or it hits the ground? Of course, if the velocity of projection is 150, just before it drops the ground, it must hit the ground with the same velocity. Can somebody confirm? Okay, so the time's sake, because of time, let me take it up. And so using the same analogy, initial vertical is 0. That is when it is falling. The time difference from the maximum height would be 8.6, because time just before it hits the ground, the time of flight is 17.2. Okay, so using v is equal to, this is 0, this is 0 plus because it is dropping, 10 times 8.6, and this is 86. Vertical velocity is 86 meter per second. Horizontal velocity is still u cos theta, so almost 123. So v squared is equal to 123 squared plus 86 squared. Can you help me with the final answer? Square root of 123 squared plus 86 squared.
The 150.1.
So the same value, exactly. So theory no dey lie. Okay, so this is it with the additional question I added, or I gave you. Question 2. Question 2, we are told that a stone is projected horizontally from the top of a tower, which is 250 meter high. Then when it was projected, the stone landed on somebody's building. You must, I think if it lands on somebody's building, then you must pay for damages. So question 2. Now, to do this, you must sketch. Just draw something. So both the building and then the tower would be on the horizontal ground. So this represents the tower, which is 250 meter high. Then the building must be shorter than the towers. Else, if the building is taller than the tower, it will not land on top. Then it must be, the velocity cannot be horizontal, it must be two-dimensional. So the stone is projected and it landed on the building. We are told the difference between the building and then the tower is 174. Now, when the stone is shot from here, it must cover this horizontal distance. If you follow the path, the horizontal displacement must be this. It must also go through a vertical displacement, which is this. This is not known. Let's assume this is y. Farida, are you there?
Yes, please.
So if this is y, we have the velocity of projection. What is the value of the velocity of projection of the stone? Class, from the question, what is the velocity of projection of the stone? It is 30 meters per second. So this stone is shot with a velocity 30 meters per second. So we have the range, the horizontal distance it must go through. We also have the velocity of projection. So we can easily find the time of flight. R is equal to U times the total time, which is the time of flight. The range is 174. Is equal to 30 times T. T can therefore be calculated easily. 174 divided by 30. And what's the answer? Right? What is 174 divided by 30?
5.8.
5.8.
8.
1.8 seconds. Note that it takes equal time to cover a horizontal distance and also equal time to cover a vertical distance. So the time taken to cover 100 and range value of 174 will be the same as the same time to cover y. So using y is equal to half gt squared, you can determine y. So half times 10 times 5.8 squared. And that should be 168.2 meter. Class, is that correct?
Yes.
Yes.
Okay.
Yes,
Good.
sir.
So we could also see that the height of the tower, which is 250, is equal to y plus the height of the building, which we don't know. Y plus the height of the building. Y is 168. So we have 250 minus 168.2. Our answer is 81.8 meter, or approximately 182, approximately 82. So please, if you couldn't attempt this problem, then this is the solution to the problem. Is there any question? Farida, is it understood?
Yes, please.
Okay. Class, I just forwarded a question, Novdek and Wasi question on projectile motion. I want you to quickly give it, just taste it. So I'm reposting the first one on the page. Yes, it's been done. The first one is saying that define the range of a projectile. Define the range of a projectile. Let me go through the list and call somebody to do that for me. Alvin Hood. Alvin Hood. Can you help us? We are to define the range of a projectile. Okay, entry Francis. Francis entry. Okay, anybody, please, time is not on our side. Anybody, it's open to all. Define the range of a projectile. What is it? Isaac Wilson.
Sir, please. The range of a projectile is the total horizontal distance the projectile can travel.
Exactly. Thank you. So the range is the total horizontal distance traveled by the projectile. Okay, B, a projectile has a maximum range of 40. Oh, okay, let me talk about this. Meaning, I'll give you a different question. Let's talk about maximum range. We've just discussed the range. Which is the total horizontal distance traveled by the projectile. There is a talk on maximum range. What is the maximum range? The maximum range of a projectile actually depends on the angle of projection, the angle through which the projectile will be fired. You see, the same question I gave you, where U is 150, where theta is 35. Let's vary the angle of projection. So calculate the range when theta is 30, when theta is 45, when theta is 60, and finally when theta is 90, and then give me your answers. So all that you are doing is varying theta. The velocity of projection is still 150 meters per second. All that you are doing is that you are varying theta. Theta when it is 30, 45, 60, and then 90. So give me the value of the range when theta has to do with the given angles. Start work. So when theta is 30, what is the range? When theta is 45, what is the range? When theta is 60, what is the range? And up to 90, we'll discuss it right after it.
Recording in progress.
Class, can we discuss it?
Yes.
Okay. So what is the range when theta is? Okay, a minute, I'm coming. Okay, so when theta is equal to 30, what is the range? Yes. Class, when theta is 30, what's the range? Can you hear me, class?
Yes, sir.
I'm waiting for your views. When theta is 30, what is the range?
Sir,
One
please.
thousand 1,948.
When theta is 45,
2,250 meters.
when theta is 60,
1,948 meters.
1,000,
948.6 meters.
0.5.
okay. When theta is 90, when theta is 90,
Zero. Says zero.
0.
0.
so which of these cases would give you the maximum range?
45 degrees.
Oh. So note that maximum range of a projectile always occur when theta is 45. It's a must. To obtain maximum range, theta must be equal to 45 degrees. And this is applied so much in projectile motion. When military personnel during war are shooting a missile, they fire it at an angle of 45. If you want to throw javelin for it to go far, then hold the javelin at an angle, estimate an angle to a horizontal around 45, and your javelin throw would go very far. If you are throwing a shot put, shoot it at an angle around 45 and it can go very far, because the range is what usually we measure during athletics. When you throw a javelin, your range is what is measured to determine whoever won the event and all that. Shot put, the same thing. Okay, so maximum range of a projectile always would occur when theta is equal to 45. And when theta is equal to 45, you see, what is the expression for the maximum range? We had range R to be equal to U squared over G times sine 2 theta. When at maximum range, R maximum, because theta must be 45, we have U squared divided by G times sine of 2 times 45. So we have u squared on g times sine of 90. Now, because sine 90 is equal to 1, equation for the maximum range is R maximum is simply u squared over j. This is the equation or formula for the maximum range of a projectile. So the rule is that maximum range of a projectile is obtained when theta is 45. And when theta is 45, the range is equal to u squared over g. So let's go back to our question. A projectile has a maximum range of 40 degrees. Determine its speed of projection when g is 10. A projectile has a maximum range of 45. So R maximum is equal to 40. Determine its speed of projection when acceleration due to gravity is 10 meters per second squared. Start with class. What is the maximum range? Well, if the maximum range is 40, determine the velocity of projection when J is 10. Sean, Dakun.
Please, 20 meters per second.
Come again.
20 meters per second.
We shall see. More views. Sean, we shall see.
The same.
You had same.
Yes, sir.
Yes, please.
Good.
Yes.
Okay. A second, I'm forwarding a second question to be attempted. It's here. So let's confirm. R max is this. Maximum range is equal to u squared over g. So if maximum range is 40, then u squared over 10. U squared is therefore 40 by 10. So u is equal to the square root of 400, which is 20 meters per second. So that's the velocity of projection. Please mark yourselves if you got that right. So these are WASI questions. Oh, WASI end of deck. So please, it's all about you understanding the concept. When you understand it well, you can solve questions at any day. I've sent question 2. Let's go through question 2. A bullet is fired from a gun at 30 degrees to the horizontal. The bullet remains in flight for 25 seconds before touching the ground. Calculate the velocity of projection. Take J to be 10 meters per second squared. Make me proud because I'm already proud of you.
Sir, please, I got 250 meters per second.
We shall see.
Yes, sir. Same.
Vasquez, you also had 250.
Yes, sir.
A bullet is fired from a gun at 30 degrees to the horizontal. The bullet remains in flight for 25 seconds before touching the ground. Calculate the velocity of projection. Take Jane to be 10. Okay, so I have had 2 answers so far. The gentleman, let me hear from you too. I'm posting the 2022 WASI questions on vertical motion and projectile motion. This time around, they missed it. So it's on the page. Are we there? Russell and the rest of you, what is your answer for the bullet from at 30 degrees with the time for the bullet remains in flight for 25 seconds question? Frank, are you here? Francis, Prince, Baki Sadek, Sean.
Yes, sir.
What's your answer?
Sir, please, 250 meters per second.
You have 250.
Yes.
Okay. Darius is also finding an answer of 250. Let's see. So we are told the angle of projection theta is 250. Hey, the angle of projection is 30. Then the bullet remains in flight for 25 seconds. So this is the time of flight. Prince, hello Prince, are you there? Prince seems to have gone to the princess. J is 10 meters per second. Calculate the velocity of projection. Calculate the velocity of projection. Okay, so share with me, how did you solve the question? Who will do that? Hello? How did you solve the question? They won't talk. So T is equal to U sine theta
all over G.
all over J. That's just it.
Cross multiply.
Good. So because time of flight is 25, we have 25 is equal to 2U times sine of 30. When we divide through by J is 10. So if we have 2U times 0.5, sine 30 is 0.5, which is equal to 250. Therefore, U would be equal to 250 divided by 2 times half is 1. So U is equal to 250 meter per second. So class, trust me, when you understand the concept, projectile motion is very, very simple. That's why I was calling Prince. Prince. A body is the WASI 2022. This is a missed up question on vertical motion, anti-gravity, and projectile motion. So a body is thrown vertically upwards. The height h attained in time t is given by h is equal to, we are told that the height h attained in time t is given by h is equal to 20t minus 49/10
T squared.
t squared. This is not projectile motion because there is no sign, meaning the question is using ut minus half gt squared. This is the vertical height traveled by a body thrown to go up at any time t. So if the height h attained in time t is given by this, determine the maximum height reached by the body. Determine the maximum height reached by the body. Let's solve this first. Then we look at the projectile motion. Class, just take a bite. Take a bite of this. 5 minutes.
So please, I got 20.42 for the
maximum height. Jocelyn, we shall see. Okay. So somebody is done. The rest of you must also try. So 5 minutes. 5 minutes to take a bite of this.
Please, I got same.
Pascaline,
20.35 meters.
we shall see. I have two ladies giving me an answer. The gentleman, I'm here to hear from any one of you. So the answer so far is at 20. Jocelyn, you said 20.
20.41 meters.
20.41.
Yes, sir.
Sir, please, I got 22.04 actually.
You
Sir,
had
sorry, 20.4. Sorry, 20.4.
okay. The gentleman, I'm waiting for you. The ladies have appointed me. So gentlemen, don't disappoint me. You must also appoint me. Sean, what is your answer? Russell.
Yes, sir.
What is your answer?
So I got 20.4.
20.4. Okay. Let's see. Let's see. I'll solve this using two different ways. The equation for height at any time t is 20t minus 49/10. So h is equal to 20t minus 49 over 10 t squared. Generally, when a body is projected to go up, the vertical height reached at any time is given by h is equal to ut minus half jt squared. So when we compare this, we can draw conclusion. When we compare straight away, it means that u is equal to 20. And we can also say that half j is equal to 49 over 10. From this, we can conclude that then j is equal to 49 over 10 times 2. And 49 times 2 over 10 must be around 9.8 meter per second squared. Class, confirm that for me. Yes. 98 divided by, yes, so that's it. So if these are the values, then at the maximum height, h max, we'll have the maximum height being equal to u squared over 2j. And u squared is 20, so 20 squared over 2 times 9.8. This is, the numerator is 400 divided by 19.6. Class, what is 400 divided by 19.6?
20 point.
20 point what?
20.40.
20.4081.
Okay, so meter. So it's in line. The second method, which wouldn't be so familiar with you because of your level, is that h, so alternatively, I have h is equal to 20t minus 4.49 over 10 t squared as what they gave me. Come in. This is what the question actually gave us. Good. I know that the rate of change of displacement with respect to time would give me velocity. So velocity is equal to the h change in height or length or displacement over the t. Okay, so if I want velocity equation, I must differentiate the distance equation with respect to time. So the h over the t is equal to rate of change. If I differentiate 2t with respect to t, what will be left is 20. The differential of this with respect to time will be 2 times 49 over 10. What will be left is t. At your level, you may not be so familiar with it. So this is the velocity equation. The velocity equation is 20 minus 49 over 5 t. At the maximum height, the velocity is 0. So at the maximum height, v is equal to 0. So if v is equal to 0, then 20 minus 49 over 5t is equal to 0. Help me find t from this equation. Help me get the value of t. T will have 49 over 5. T, when it crosses the equal to sign, it will become positive, is equal to 20. Therefore, T would be 20 times 5 divided by 49. Class, what is 100 divided by 49? It must be 2 point something. Hundred divided by 49, class.
2.04.
04 seconds. Meaning that it would take this time to reach the maximum height. Okay, it will take this time to reach the maximum height. If it will take this time to reach the maximum height, then come back to use this equation. Come back to use h is equal to 20t minus this. Substitute your value of t into this equation. So we have 20 times 2.04 minus 49 over 10 is 4.9. 4.9 times 2.04 squared. Yes, what's the answer? Twenty times 2.04. Then you subtract that.
40.8 minus 20.39.
40.8 minus
20.39.
Okay, so I'll put 20.4. And this will also be 20.4, isn't it?
Yes, yes.
So this is the second method in solving this. But frankly speaking, the second one wouldn't be so familiar to you because of your level in mathematics and physics. Okay, so class, the same question. There is a second question which is on projectile motion. A projectile fired from the ground level with a speed of 20 meters per second just missed the top of a pole 5.2 meter high. Calculate the angle of projection with respect to the ground. Take Jane to be 10. The second question of the 2022 question. A projectile fired from the ground level with a speed of 20 meters per second just missed the top of a pole 5.2 meter high. Calculate the angle of projection with respect to the ground. Okay, so what I will do is that I'll send another question. Okay, I'll send another question. Do it and then quickly send it to me right after the class. We have about 10 minutes to go. Tomorrow, we will begin with vectors. Yes, we'll start with vectors. I'll send another, let me send it right away.
Please, I have 30.7 degree.
Don't call your answer out. Okay, so class, I've sent another one. This is I think what's it 2024? And NOVDEC rather 2024. Two balls X and Y are projected from the same point at an angle theta to the horizontal. So two balls X and Y are projected from the same point at an angle theta to the horizontal. If X is projected with an initial velocity twice that of Y, if X is projected with an initial velocity twice that of Y, calculate the ratio of the time of flight of X to Y. Okay, so two balls X and Y are projected from the same point at an angle theta to the horizontal. If X is projected with an initial velocity twice that of Y, calculate the ratio of the time of flight of X to Y. So the ratio is such that it is X to Y. Okay, the ratio of the time of flight of X to Y. So you answer this, and then the first one, what you are currently working on, and send it to me right after the class. You have barely hello.
Sir, please, are the questions on the page? I got disconnected, so I don't.
Yes, the questions are on the page. Okay. The first one, and then this current one, I'll highlight on them. Okay, do it and send it to me for marking, please. I expect each one of you to send something. Send your work. Okay, you are currently 48, 47, meaning some of you are gone. Let me at least have about 50. I'll use this as your assessment. Your first test will be used, your exercises, and the second test. So please, if you couldn't partake in the first test, send me a message so that I give you something to work on, because you will be given a report. This is where I end today's show. Thanks so much for your presence, your involvement, and everything. We'll continue same time tomorrow. May the good Lord be with you, and bye-bye.
Bye.
So if you didn't do the first test, send me a personal message. So I put something together for you. You do something. I send you work to do, else it would affect your report.